Alright, this video is about a particular kind of thermometer, which has very specific uses. It's called a thermocouple. Thermocouple. Basically, you make this kind of thermometer by combining two separate wires, really three, but basically you combine a couple of wires that are made of different metals together in a specific way, and then hook them into a circuit. Obviously, we have not talked about electricity yet, so this is not going to completely make sense to you yet, but we'll revisit this topic again probably in class when we do electricity, and then hopefully it'll make a little bit more sense, but you should be able to get the basic idea right now, okay? So, here's a picture. I included a picture of a guy basically using a thermocouple to measure the temperature of lava directly. That's kind of crazy. You can see where I got that picture from. Okay, so let's move on, talk about some specifics. Alright, so this is a really basic schematic diagram. Obviously this is nothing like what a thermocouple actually looks like. If you were to hold one in your hand, it basically just looks like a metal rod. But inside of that metal rod, this is what's going on. All this stuff kind of hooked together. So you have basically three separate metals usually. One of them is, it varies from thermocouple to thermocouple. It depends on what you're trying to measure with it. So different combinations of metals have different ranges and so on, which we talked about in the previous video. Range of the thermometer. So basically the metals are chosen based on the range of temperatures that they can measure. Anyways, you'll have one kind of metal here. In this part I represented that with green. Another kind of metal here which is different from metal A. And then metal C is usually something totally different as well, that has good electrical properties. And then that is used in the rest of the circuit, which is over here. I did not include that. It's not necessary to you right now to know that kind of thing. Just know that basically you've got metal A bonded to metal B here at what's called the hot junction. That's where you actually measure the temperature right there of whatever thing it is that you're trying to measure. And then metal A then hooks up to the end of this processing circuit, which is metal C. Metal B also hooks up to the other end of the processing circuit. This junction here is called the reference junction. It used to be when they first made thermocouples that this would be basically pure melting ice as the reference junction, but these days they don't use that kind of a thing. They just use some electronic circuitry to make this reference junction. Alright, so that's the basic structure of a thermocouple, and the reason it works is that basically these two different metals have different properties, and the fact that they're bonded together here and then bonded to a different metal over here at a reference junction, they'll have different, what's called potential difference, or a different voltage from this point to this point in metal A and from this point to this point in metal B. So the difference in the potential, the difference in the voltage of these guys is what lets you measure the temperature there compared to the temperature here. Basically, it lets you measure this temperature. It's, again, like I was saying, it's not going to totally make sense to you right now, but the basic thing you need to know here is that a thermocouple uses a difference in voltages. It uses electrical properties. Difference in voltages between the two metals, and that lets you, based on how big that voltage is that you get, the voltage reading that you get here in the processing circuit, based on that difference in voltage, you're able to calculate how much temperature change occurred. Okay, in other words, you can calculate the temperature of the thing. It's a long, complicated explanation, but the main thing you need to recognize is that there's two separate metals. They're bonded at a hot junction, right? And that's where you actually measure the temperature. They're also connected to a third metal at a reference junction, and then that allows you to calculate the temperature, which is all done electronically these days in the processing circuits. And essentially all you will look at if you're using one of these is a little screen over here that has the temperature. on it. All right, cool. All right, so what's the purpose of a thermocouple? Well, you can see all of the things right there in the screen. Why use a thermocouple? Well, first application, measure very hot temperatures. All right, you cannot stick a mercury thermometer into lava. Not going to happen. All right, that thermometer will break, guaranteed. You can't use it. You need something else. So molten metals, say like a foundry where they're melting down iron or, smelting other metals, and they want to know the temperature. They need some other way of measuring it than a liquid in glass thermometer, or even some of the digital thermometers you might use for measuring body temperature and so on. You need something a lot more robust than a meat thermometer or whatever. You need something that is made of a material with a very high melting point so that the thermometer doesn't melt when you put it into the molten metal, right? Anyways, you need these things to be able to, so you need a kind of thermometer that can measure very hot temperatures, and that's a thermocouple. All right, you can use metals with very high melting points, and that allows you to measure other metals with lower melting points after they're melted. All right, other thing that you might use a thermocouple for is rapidly changing temperatures. So some kinds of thermometers don't react very fast to changes in temperatures. They're slow to react. Thermocouples are very quick. They change. They react very quickly, and they have digital readouts. It's all electronic, so you can find out very quickly and measure that rapidly changing temperature with a lot of accuracy. So first, we can measure very hot temperatures. Second, we can measure rapidly changing temperatures. And then third, we can measure a wide range of temperatures because, a thermocouple is made out of metal, and metal is solid for a very large range of temperatures. So the electrical properties remain constant. It remains linear. It remains linear over a very large range of temperatures. So if you need to measure a whole bunch of different temperatures, like say ranging all the way from below 0 Celsius all the way up to maybe several hundred degrees Celsius, a thermocouple is the best option because it lets you measure a huge range of temperatures. All right, cool. That's all I've got for you in this video. See you next time.